Okay, guys, here we are. It's another opportunity to learn more about Geogebra. This time, we are starting chapter 8, and we're going to learn about transformations in geometry. The first two lessons are going to be about the concept of dilations. Then we're going to talk a little bit about translations, rotations, and reflections on the coordinate plane. So we're going to start um, taking into account that you are going to do an activity that is already uploaded in Canvas. So hopefully this video is going to help you go through the activity. Let's begin. Here we are in Geogebra Classic, and the first part of the video, or sorry, the activity, I'm going to do these two videos. The first one is about the part one of your activity. So in this part one, you will have to dilate a triangle. So the first thing I am going to do is use the polygon option, and we're going to draw a triangle, but please make sure you are not going to be the same I am going to do. You have plenty of options here to draw any triangle, but make sure that you are going to use coordinate pairs using integers to make your life easier. If you want to make your life harder, you're going to choose any point located over the coordinate plane, but I would suggest you use one that is easily identifiable, like the ones I'm going to do. So before that, probably I'm going to move this a little bit down over here to be able to draw I think a larger triangle. So what I'm going to start doing is locating the vertices of the triangle. The first vertex is right here. As you can notice, this are the coordinates x equals 6 and y equals 2 for the first vertex. Let's use the second vertex right here at 3, 7, and a third vertex located at 10, 6. So we're going to finish the figure, and we already have it. Then it's going to provide more information about this polygon. But here, in some kind of bluish color, you see the coordinates of the original, or we also call it pre-image. The first command, or the first instruction we have, is to scale by a factor that is greater than 1. So as you can notice, this function here that is dropping down different options, these are all the transformations you can do using GeoGebra. Here's the last one. This is the one we're going to use to work today. So we're going to dilate from a point. All of the transformations we have, or especially in this case dilation, are going to be from the origin. So before I use this command, I'm going to use the command point, and I'm going to locate a point right at the origin of the coordinate plane. As you can see, point D is located at the origin, 0, 0. And then now we can use the dilate instruction. As I dilate it, please take a look at the bottom of the screen, and you will see the instruction dilating from the point. The first thing you do is select the object, then the center point, and then you are going to select a factor of dilation. In this case, we are going to enlarge this figure, this triangle, and we're going to click on dilate. First we select the object, then we select the point of dilation, and the factor I'm going to use in this case is going to be 3. It means that I'm going to enlarge this triangle by a factor of 3. And now you can take a look at this. You don't see it on screen, but if I zoom out, you can notice something. I'm going to move this. This is what happened. You can see an enlarged triangle. Some characteristics, you can see that they are similar. Similarity means that we keep the same measures of angles. For example, look at this. We're going to measure this angle. Oh, wait a minute. I think I used the wrong one. Angle, yeah. So let's measure this angle, the angle B. It's 1591 degrees, and we are going to measure it here. As you can see, when we're enlarging, we keep the angles. Also, you might notice something as well. We're going to measure the distance of the original or pre-image triangle. This one is 707. Remember, the dilation factor I used was 3, so guess what this segment will be if this is approximately 7 and the dilation factor was 3. I'm guessing that you're thinking of 7 times 3 is going to be 21 point something, and here it is, 21.21. This is what we're doing as a dilation of, if I am using a factor that is greater than 1, I am going to enlarge. Now, I'm going to do a second dilation, but this time the dilation will be using a factor of 1/3. So now you can guess what is going to happen. Again, I'm going to use the original or pre-image figure. I'm going to do the dilation from the center, and then the factor is going to be 1/3. Let's see if Geogebra reads that way, and I think that it will. Yep, look at this. This tiny triangle is the one we wanted. As you can notice, if we measure this distance, you know that it's going to be some 707 divided by 3. Yeah, you can use a calculator and you can notice that, but remember, we keep the measure of the angles, and I'm going to measure it just to make sure. Notice this, 50. Okay, you can see it quite better over here. This is the dilated triangle, but a smaller one by a factor of 1/3. One more thing I want you to notice is this thing. Take a look at the coordinates of the point B prime. Let's look it up over here. B prime, because this is for the second one, but B prime has to be somewhere over here. Look at this, it's 921. Where is the original B? It's right here. Remember, it was 3,7, but as it is over here and it was enlarged by a 3, you can notice what is going on. 3 times 3 is 9, 7 times 3 is 21. One last thing I want you to notice. If I try to draw a line that passes from the origin, look at this, how these 3 points are connected. What do you think if I do it for the other points? You're right. It's going to be, or all of them are going to be connected as well. And this is how we do dilations. In this case, from the pre-image, the original image we had, or figure, we could enlarge or, reduce the size of figures, and all of these 3 triangles are similar. Well, this is the end of our first